All right, so we are reviewing some fraction stuff this week. This lesson is adding and subtracting fraction story problems. Before we can get into the story problems, I just want to review some things about adding and subtracting fractions. To add or subtract fractions, you first must find a common denominator. Okay? Shh. Do not make comments, just write it down. It's what we have to do. Okay? So to add or subtract fractions, you first must find the common denominator. Also, we want to make sure that we simplify. Some of us still use the old word reduce. Your answers. That should say your answers, not you answers, but that's a typo. That's my fault. Okay? And then when you're done, you're going to change any improper fractions to mixed numbers. Okay, so I made this fill in the blanks. That would be fairly fast. But these are the things we want to make sure when we're working. So to add or subtract fractions, you first must find the common denominator. After you've then added or subtracted, you're going to simplify your answers. Simplify is the word that we now use for reduce. Okay, and then you're going to change improper fractions to mixed numbers. Those are the things that need to happen. Okay, so we are taking notes. Everybody should have a pencil in their hands, nothing else right now. We're going to go into the story problems. We're going to be drawing a lot of pictures for these because some of you seem to have issues figuring out whether you're going to add or subtract. We did this with decimals. But if you draw a picture, you'll be able to figure that out. All right, so let's read through the first one. Becky has been monitoring her mileage. So that is driving a car or a truck. According to last week's driving log, which we keep here at school on the Suburbans, she drove 3/10 of a mile in her car and 1/2 of a mile in her truck. She must live in a big city because that wouldn't seem like a big deal in Lake City. But if she lives in a big city, that might be a big deal. How far did Becky drive last week in all? So we're going to draw just a quick picture. So here she is starting off, and she drove 3/10 of a mile in her car. So that's what we just got from here. And she drove 1/2 of a mile in her truck. So then she did 1/2 a mile in her truck. And it wants to know how far did Becky drive last week in all. Now, in all is a key phrase that should tell us what to do. So raise your hand if you want to tell me. We're going to add or subtract. Brian?
Add it.
We are going to add. So we're going to add 3/10 and 1/2 together. All right. So we need to think about common denominators. I can't add tenths and halves together. So what needs to happen?
You times the 2. Yeah.
By what?
By 5.
Okay, so we are going to multiply the 2 by 5. And why are we doing that? So we have a common denominator. So that's going to give us 5/10. So now that I have common denominators, remember when you're adding, the denominator just stays tenths. And the numerator we just add. 3 plus 5 is 8. Okay, so we were following what was in the box. We found common denominators before we added. So now we need to see if we can simplify our answer. Can 8/10 be simplified? Can it be reduced? Tommy?
It can be reduced to 4/5.
Okay, so we could divide both of these by 2. Good. And then it would be 4/5. Now, something else we should do is we should be labeling. What was this being measured in, this distances? Miles. So I need to make sure that I put miles on my answer, or at least an MI. Because these are story problems. We need to know 4/5 of what? Is it 4/5 of an inch? 4/5 of a centimeter? 4/5 of a kilometer? 4/5 of a mile? I guess it wouldn't even be miles. It would just be 4/5 of 1 mile. It's not very far. Although if you live in a big city, a lot of people can get to everything within a few blocks of their house. And so she might just be keeping track of this. Or I don't know. I mean, you could think about maybe it was a bicycle instead of a vehicle. Maybe that would make more sense for where we live. All right, so let's look at the second problem. Professor Alexander weighed 2 pieces of metal for an experiment. The piece of iron weighed 2/3 of a pound. I'm going to underline that. That looks important. And the piece of aluminum weighed 1/2 of a pound. How much more did the piece of iron weigh than the piece of aluminum? So this is what we're trying to figure out. So I'm going to read through it again, and I'm going to draw a picture. So Professor Alexander weighed 2 pieces of metal for an experiment. The piece of iron weighed 2/3 of a pound. I'm going to draw just a little box to represent the iron. I'm going to write iron, and I'm going to put 2/3 of a pound on that. And then the aluminum weighed 1/2 of a pound. Okay? So aluminum is 1/2 a pound. So you can kind of imagine we were putting this on a balance scale. It would look like this, right? Because we know that the iron is a little heavier. And it's also know that because of the way they worded it. How much more did the piece of iron weigh than the aluminum? So this one's heavier, okay? So you're right. We are going to subtract to figure this out. So the iron is the one that's heavier. So we are going to subtract the 2/3 minus 1/2. Now raise your hand if you can tell me what the common denominator is going to be for the 3 and 2. Go ahead. 6. Okay, so to get 6 out of 3, I'm going to have to take that times 2. And then I have to take the top times 2. And to change halves to 6, I have to take 1/2 and take it times 3. So 2 times 2 is 4, so that would be 4/6. And then 1 times 3 is 3. 2 times 3 is 6. So I end up with 4/6 minus 3/6. When we're adding or subtracting, remember the denominator just stays the same. So we get 6, and then 4 minus 3 is just 1. Now I need to label this. This is a story problem. 1/6 of what? Pound. That's 1/6 of a pound. So that's how much heavier this iron was than the aluminum. Okay? All right. So I'm going to go down to the next part. So it says the chef of a pizza place used 9/10 of a package of pepperoni and 1/6 of a package of sausage. And that's supposed to say for a pizza. I think I got excited when I was typing this yesterday and left some pieces out, but we'll just manage. It's okay, so I was in a hurry. So it's 9/10 of a package of pepperoni and 1/6 a package of sausage. That's all going on one pizza. Evidently it's very heavy on the pepperoni. Okay, so you might be thinking about your pizza. Okay, so you might draw a circle to represent your pizza. You might put some toppings on your pizza. Whatever you need to do to make it seem like a pizza to you. It doesn't have to be fancy. And then we need to think about what's going on here. So we're putting 9/10 of a package of pepperoni. I'm going to put pep there for pepperoni.
Pepper.
And we're putting 1/6 of a package of sausage. I just labeled that. Okay, I meant to put the 1/6 on here. And that is sausage. Okay, and those are going onto this pizza. Okay? So it says, how much more pepperoni than sausage did the chef use? When I see how much more, that key phrase, what operation is that telling me to use? Raise your hand if you know. Brian knows. Tell me.
Adding.
Oh, I think you had it right the first time. Somebody else want to try? Go ahead. Subtracting. No, how much more this is than this. So how much more is keywords that mean subtract, because you're trying to find that difference. You're trying to find a difference. Difference means subtract. I think you had it because you started to have an S sound first and then you changed your mind. So we are going to subtract the 9/10 and the 1/6. Now, I could use 60, but I think that might be big. You can list out multiples of 10 and 6 to find the least common denominator. You don't always have to use the smallest, but it'll make less reducing later. So if I write out my tens, I have 10, 20, 30, 40, 50, 60. If I do 6s, I have 6. What comes next? 6 times 2 is 12. 6 times 3 is 18. 24. 30. Oh, look at that. 30 is going to be my least common denominator. That's my least common multiple, just the same thing as least common denominator. So to change 10 to 30, I'm going to take 9/10 and multiply by 3s. And to change 6 to 30, I'm going to do 1, 2, 3, 4, 5. It's times 5. See how I counted that out when I listed it? 1, 2, 3, 4, 5. That tells you, oh, it's 6 times 5. So it'd be 1, 6 times 5. And that'll give me 30. I could use 60. And if that makes more sense to you, you can. But you'll have more reducing on the end. So we'll end up with 27 30ths minus 5 30ths. So I know 30 goes on the bottom. What's going to go on the top?
22.
22, good. And can that be reduced? Yes. Now if we'd use 60, it would have even more reducing. So first of all, I notice it's even, so I'm going to start just by dividing by 2 and see if that'll just do it. So 22 divided by 2 is 11. 30 divided by 2 is 15. I think that's as far as I can go because 11's prime and it doesn't go into 15. Okay, so I need to remember exactly what we were measuring. 11/15ths of what? So this was 9/10 of a package and 1/6 of a package. And I guess we're making the assumption that the packages are the same size. And so this would be 11/15ths of a package. Now I noticed another typo, but it's actually going to work out in our favor because we used all this space. All of this is supposed to be up on here on part B, and I don't know what happened. I didn't notice it when I was copying this. It moved down here.
No, the second question on the A part. Yeah, it's supposed to be on B.
Oh, that's supposed to be on B. How much more meat did they use in all? Oh, so we didn't read that part. So we still need to do B then. So how much meat did they have in all? Here's that in all again, which tells us we need to add. So that was part A. Oops. So then if we're doing part B, we've got to add the 9/10 and the 1/6. Now here's the good news. We already changed those fractions to be common denominators. So really, I could just start with the 27 30ths and the 5 30ths and add those together. Okay, so 27 30ths and 5 30ths, that's 27 plus 5.
32.
32. Now, a couple of things need to happen here. It's improper, so we need to change that first. Who can tell me how to change this to a mixed number? Go for it.
1 and 2 30ths.
Okay, so why do I know it's 1?
Because 32 isn't twice 30.
All right, because 30 only goes into 32 one time. So we're kind of thinking division in our head. And then if I subtract that, there's 2 left over, and I have 2 30ths. And then I can just reduce the 2 30ths. So yeah, divide it by 2, and we get 1 and 1/15th of a package that we used in all. So I know people struggle with this, changing the improper to a mix. So I'm going to show you another little trick that we used a lot last year. You could set this up as a long division problem, which I know, oh, long division, but really it helps. So 32 divided by 30 would look like this. So 30 goes into 32 one time. 1 times 30 is 30. And then the remainder, the 2, goes on the top, and the 30 goes on the bottom. So your remainder becomes that fractional piece that's left. This is something that we used a lot last year, if you were in my class last year. There's lots of different methods, and I'm not sure what you guys learned in elementary, but this is another tool that you could use if this was confusing back there. Okay? So let's go ahead and look at the problem on the bottom. So it says 1/4 of the students in an art class are currently painting with watercolors. Another half of them are painting with oil paints. What fraction of the students in the art class are painting, whether with watercolors or oil paints? So what we want to think about here, when I see 1/4 and 1/2, I suddenly want to think about those pictures we started with in elementary. Do you guys want to use a square or a circle? What do you think?
Square.
Square, okay. So I'm going to draw a square. And then I'm going to divide it into fourths because 1/4 of the students in art class are currently painting with watercolors. I don't want to write watercolors in there. I'm going to do WC for watercolors right there. So this is the kids painting with watercolors. And then another 1/2 of them are painting with oil paints. So I could do a half over here, and I could put oil paints over here and think about shading that in. With my picture, I just solved that without actually doing any actual math. Yeah. What is that fraction? 3/4.
Oh, peasy teasy.
So 3/4 of the class are painting. So this is 3/4 of the class. And if you have one of those super easy ones where you can solve it with a picture, I'm going to let you do that. Because this is a problem-solving strategy. You could still write out the 1/4 and the 1/2 and find the common denominator. So I'll do that really quick. So to change halves to fourths, we just multiply by 2 and you get 2/4. This is pretty straightforward too. You get 3/4 this way. But this one's really easy just to solve with a picture. And I wanted to point that out, that that's a problem-solving strategy. When we're doing things like map testing or part testing or whatever, I want you to realize that sometimes you can solve things with a picture, and this would just be like a way to check. Okay, does that make sense? All right, so any questions on that piece? About ready to go on? A couple people are still writing, so I'm going to pause for just a second. Let them write stuff down. I'm going to take a quick look. Think everybody's got it. So on the next page, we are almost done. I just spread this out so we'd have room to write. Okay, so Franklin made an apple pie. When I see the name Franklin, I always think of the turtle. I don't know why. Franklin the turtle always pops into my head. So maybe he is a turtle. He's making an apple pie. He used 3/4 of a tablespoon of cinnamon and 1/3 of a tablespoon of nutmeg.
May I use the rest?
Yes. And he wants to know how much more cinnamon than nutmeg did Franklin use. When I say how much more, that means they're looking for a difference. And when we're looking for a difference, are we going to add or subtract? Subtract. So when I see how much more, that's a clue that we're subtracting because we're looking for the difference between things. And if you don't remember, difference is a word that means subtraction, the answer to a subtraction problem. So he's using 3/4 of a tablespoon of cinnamon. So I'm going to draw a spoon because I am not good at drawing, but it'll be all right. So this is a 3/4 a tablespoon. This is cinnamon. I'm just going to put C-I-N on there. And then he's using 1/3 of a tablespoon. I'm really bad at drawing. I'm sorry, guys. I don't know what I'm doing. I drew the first one fine. I don't know why this is so hard. All right, so I'm going to draw the second one. So this is 1/3 of a tablespoon, and I'm going to call that nutmeg. So I'm just going to put nut on there. I know that that's nutmeg. Okay? So if it's looking for difference, we're trying to figure out how much more cinnamon there is than nutmeg. This one's bigger. Okay? So we're going to take 3/4 and subtract 1/3. And they're actually telling us which one's bigger. How much more cinnamon than nutmeg did Franklin use? So it's telling us that the cinnamon is more, which is a clue that that number's got to go first. All right, so what are we going to use for a common denominator for 4 and 3? TJ? 12. Good job. So I'm going to take this 4 times 3 on the top and the bottom. And I'm going to take 1/3 and just multiply by 4. That's a pretty easy one because you can just use 3 and 4. So 3 times 3 is 9. 4 times 3 is 12. 1 times 4 is 4. 3 times 4 is 12. All right. We should get 12ths for both of them. If we don't, then we mess something up because we're trying to get common denominators. So we just need to take 9 minus 4. So what's 9? Good, 5. So we get 5/12ths, and this is all being measured in tablespoons. This is a capital T. BS if you're using an abbreviation. All right, then down here it says how much total spice did he use. If I see the word total or in all, that means that I am looking for a sum, which means that I'm going to add. So look for these key words because they're clues into what's happening. So I already have my common denominators over here, I'm just going to change subtraction to addition and add 9/12 and 4/12 together, which is 13/12. Okay, so if you're struggling to switch this, we're basically taking 13 and dividing by 12. The top of the fraction goes inside, bottom of the fraction goes out here. So how many times does 12 go into 13? One time. 1 times 12 is 12. So that means there's one fractional piece left over, and that's 1/12. So it's going to be 1 and 1/12 tablespoons of spices in all going into the apple pie. It's just making me hungry. Okay? So this is your practice problem. So I'm going to stop.